we have defined vectors in xyz coordinate system. So if I again go back on xyz coordinate system, so a unit vector in a x direction is nothing but a vector in which if I move, x is going to change. If I consider a vector in a y direction, a unit vector in a y direction, it's a vector. If I move in that direction, value of y is going to change. In a similar pattern, if we consider defining vectors in terms of rho, phi and z, rho and a rho has to be a vector. By moving in that direction, rho has to vary. So friends, what do we know? Rho is going to vary if I move away from an origin of a center of a pipe towards the outer side. So if I consider arrow direction, so it's the direction in which if I move, radius of a pipe is going to change. So arrow is a direction in which we are moving away from the center of the pipe. In a z, if we move in a z direction, z is going to change. So az cap would be the direction in which z is going to change. But now we need to look after a unit vector in a phi direction. For that, consider again a pipe inside xyz coordinate system. From front side you can see a circle. So friends, phi is going to change by moving or by rotating OA line on a circle. So what we can see over here, phi is changing in a direction which is tangential to the all points on a circle. So a phi direction is nothing but the direction in which phi changes, and that is tangential to each and every point of the circle. So after defining a rho direction, a phi direction and az direction, now let us consider vectors and their line integrals. If I consider a vector in an arrow direction, consider it to be 2 arrow. So 2 arrow would be a vector in the arrow direction. I can break it into small length of d rho length looking towards arrow direction. If I integrate all these small lines, I would get a whole line 2 arrow. So to define a line integral in arrow direction, we would integrate d rho in arrow direction. Now let us come to line integral on a phi direction. So friends, here something is different. In case of a phi direction, we can see the change is not linear. It's a non-linear curvature change. To consider line integral in a phi direction, we need to divide whole phi angle into small d phi angles. So friends, here I need to find arc length by changing phi by d phi over rho length. So if I consider the length of this arc for radius r and theta being a d phi, arc length would be rho d phi. If I integrate this small angles of d phi over a line, I would get a whole phi change. So a line integral in a phi direction is defined as integration rho d phi in a phi direction. And if I consider line integral in a z direction, and z being a linear coordinate, we would have a direct line integral which would be integration of dz in a z direction. So friends, if I consider a 3-dimensional vector in a rho phi z coordinate system, we can have a line integral defined as integration of d rho arrow direction plus rho d phi arc length rho d phi in a phi direction plus dz a z direction. Now, after mastering this line integrals, let us learn surface integrals in case of cylindrical coordinate system. So, what we have learned from the xyz coordinate system? For a surface, direction is perpendicular to the plane. So here, if I want to have a surface which looks towards arrow direction, so if I consider a vertical pipe, curvature of a pipe looks in an arrow direction. So for curvature, I'm considering the curvature which is a surface, and I divide the whole curvature into small surface. It has z change, that means height change, as well as phi changes. So being an arc change, a non-linear change, this change would be rho d phi, and this height change is dz. So surface, which is the arc of a surface which is a pipe, surface of a pipe, it looks in an arrow direction where phi changes and z changes by the amount of dz, and this arc would be rho d phi. Surface integral is defined as surface rho d phi into dz in an arrow direction. Now, if I consider a surface which looks in a z direction, so a surface which looks in the z direction, there rho is going to change by d rho. At the same time, curvature would be there because of the phi. So if I want to have a surface integral in z direction, it is because of change in d rho and because of a curvature change of phi, which is defined as surface integral rho d phi d rho in a z cap direction. And if I consider a surface which looks in the phi direction, it has a change in a rho and change in a z. Change in rho being a linear quantity, change in z being a linear quantity, we would have a simple surface which has a change area of d rho dz. So surface integral in a phi direction is defined as integration of d rho dz in a phi direction. So all these three surface integrals, if I combined, the overall surface integral becomes integration rho d phi dz in arrow direction plus integration d rho dz in a phi direction plus integration of rho d phi d rho in a z direction.